I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Joan Wills, Executive Director, Cummins Software and Electronics Engineering, and Sibley Nebergall, Partner, Boston Consulting Group. On today's episode, we'll learn about the mobility industry's need for more engineers and how the 40 by 30 initiative will increase women engineering graduates from 20% to 40% by 2030. We hope you enjoy this episode. Welcome to the podcast.
Yeah, thanks for inviting us.
It's great to be here.
It's wonderful to have you here. Engineering's cool. It's a great career path. It's a great career path for millions of children that want to go on and make a difference in the world. We set the spaceship up. It was engineering. The car that drives on the road, it's engineering. The table in your house has engineering and math in it. And simply Boston Consulting Group published some real interesting data, and I found it eye-opening, is that every year the United States will need roughly 400,000 new engineers. That's a lot of engineers. How's that talent pipeline going to be filled?
It is a lot of engineers. I will not dispute the need. I hate to say it, but I don't think there's a silver bullet here. But the imperative is so strong that we can't afford not to address it. From a U.S. competitiveness perspective, especially given our energy transition goals, there's a potential $450 billion of lost economic output put at risk due to the lack of engineering talent. And American companies know this. There was actually a letter sent to President Biden recently by the American Council of Engineering Companies, representing 6,000 companies, saying that the talent scarcity for engineering and design talent actually is putting at risk the Build Back Better Act. And so there is a real need for competitiveness here. And unfortunately, we can't actually import or immigrate our way out of it. Japan has a 700,000 engineering shortage. Germany has, I think it's 320,000 engineers that they're short. So this is something that we need to resolve as a need, and we sort of can't rest on our laurels and not address. I know that's not the answer to your question directly yet, Grayson, but I think it's just a critical point to start with in terms of how severe that need is. In terms of how you address the talent pipeline, I think it's an interesting piece because if you actually dig into the numbers, we have an oversupply of some types of engineers and an undersupply of others. So for instance, we actually have, if you drill down into sort of job categories and workforce needs, more mechanical and chemical engineers than we need. But we have a big undersupply of electrical, for instance, big undersupply of software engineers. And so it's important for us to disaggregate and actually get a little bit more fine-tuned in terms of our grain size to really understand sort of the root of the problem. And then when you're trying to address it, and Joan, I'll ask you to speak to this as well in a minute from sort of the industry perspective, we need solutions all the way through the talent pipeline. So we need more students studying these prereqs in high school. We need more grads in college and actually entering the workforce. So right now, there's about a drop-off of 50% from folks who say they're interested when they enter college to those who actually graduate with engineering degrees. And then there's another 30% drop-off when you go from folks who are graduating with engineering degrees to folks who actually enter into the workforce. And you need to keep people in the workforce once they're in these engineering-related roles. So when you look at folks early in their career versus all the way through to mid-career and later career, there's actually about half of them leave the engineering role space, and it's even worse for women. So if we're looking at ways to address, I think we feel pretty strongly that you need initiatives all along the talent pipeline, right? It's not enough to just address it sort of with one lever at one point and across multiple time horizons there. But we're really excited, and here I'll pass it to Joan, because I think recognizing sort of those many leverage points, we really see an opportunity for sort of coalition leadership to help cross-sector efforts across education, industry, government partners, social sector partners to deliver that sort of constellation of initiatives. And SAE's 40 by 30 initiative is actually part of the ambition is to spark that coalition. So I don't know, Joan, if there's anything you want to add to this.
Yeah, thanks, Sibley. Great overview. And I agree there's not one silver bullet to this issue. I want to touch on first, Grayson, you asked why now, why we have such a big shortage now. And it's a combination of things, but the primary one is this clean energy transition will be really tough and complicated. And there's no one technology that will enable the transition fast enough for our global warming imperative that we need to stop. And so the mobility industry is facing this, and there are many technologies that many different stakeholders will need to invest in to enable this transition. As Sibley said, there's a lot of good work going on in a lot of different places. So I'm proud to be a trustee of the SAE Foundation, which does STEM education programs and curriculums, some of which, if you go to the AWIM website, you can go online and use from home. But their primary goal is to work with teachers in the classrooms with volunteers coming in that can role model the purpose of engineering, to be engineers and be visible to students who maybe don't see any other engineers in their lives. And if they're looking around the adults that they look up to, they may not see any. And so making that visible, making that accessible throughout K through 12 and into college is one of the big things the SAE Foundation works on. And there are many great programs that do things of that sort. Cummins, I'll just touch on a few things there. It may be surprising, and I've been surprised when I uncover these. There are still, in some cases, physical and legal barriers for women in engineering. So as we looked around at all of our service stations, we need restrooms for women. There was a place I visited at a rebuild center for some of our engines in Dubai where it was actually not legal for women to work as technicians. And so we worked through that with the local government, and we have women now as technicians. But don't overlook that, I guess. There are some just really basic things that we need to do as a society to enable, half the world's women. And if we want this many more engineers, we need to remove some of those barriers. And then there are many other things that you can do and will need to do, but I know we'll touch on some of those in the later questions. So I'll turn it back to you.
Sibley mentioned there's a shortage of electrical engineers and software engineers. Does Cummins have an apprenticeship program? Perhaps there's an engineer that wants to learn a new skill so that they can get mentored by another individual to learn that skill set. Is there anything like that going on inside of Cummins?
Definitely. So we have a number of things. So as the engineering leader for software and electronics, I've actually hired hundreds of software and electronics engineers, and many of them are people that know our products really well and want to figure out how to translate their analysis from a mass spring damper system to an RLC circuit, or learn to code, and learning to code with some of the new tools actually is quite accessible. So, one of the things I would encourage engineers to think about is, and we've actually done some analysis of undergraduate programming, the differences between the types of engineers are not that large in terms of total number of classes. And with technology changing so fast and the tools and processes that we use, problem solving is the same across many types of engineering, but learning a few new skills is very accessible and very important. And so, yes, a number of the people that I've hired within my organization who are doing software and electronics now have a traditional background in mechanical engineering.
So, but you mentioned something that it's resonating throughout this conversation, the drop-off rate, where a student goes through an engineering and they drop. What causes that drop rate? Because it seems to go up, unfortunately.
And I'll confess, I'm not sure I have the full stop answer for you as to what exactly causes that, but I will speak to a couple of the things that we see as drivers. One is sometimes you look at it in sort of the K-12 space. And I think when we think about initiatives there's both sort of an academic component, but there's also sort of an identity component. And so honestly, I think we want our K-12 students to be exploring. Right? We want them to be changing their mind and growing and evolving. And so I wouldn't say that, a change from interest to sort of execution, so to speak, in the K-12 space is necessarily a negative if we've got sort of appropriate representation. Unfortunately, we don't from the young girls and women's side. So there is something to unpack there around, I think particularly on the identity side, do girls and women, especially as they're getting into sort of that middle and high school adolescent bracket, have the role models that Joan was speaking to, such that they feel from an identity perspective that it's not like I'm going to sort of stereotypically go hang with the boys now, or I can't be both a girl in whatever manifestation I want to bring that into my school and classroom with, and also be super strong in STEM and super strong in science and interested in the careers that I see on the flip side. So not sort of having a little bit of sort of a chilling effect from where they'll be in their future aspirations. But then as you go up, I think going back to Joan's point, there are some systemic sort of barriers in the workforce writ large, right? We know that. I think if we want to talk about how would you unpack some of that, maybe two thoughts here. One on how you can unpack it, and then the other on like now being the moment I would advocate. I think there's some really interesting research that BCG has done around what people say will keep them in their role versus what actually keeps them in their role. And if you parse it, we sort of bucket them by like functional needs. So like your salary, sort of timing of when you're working, et cetera. Like Joan, to your point, like, are you working in person or virtually versus emotional needs? So do you feel supported, valued? Do you have community at work? All of that. And what we found was actually some of those emotional needs were much bigger drivers in terms of whether people actually shifted or left than the functional ones, and particularly in terms of what your direct manager sort of engages with you on. So the role of middle managers is being just really, really critical. And so when we think about sort of the follow-on effects or the compounding effects of a shortage of women in the workforce, if you're getting up into those managerial roles and there are fewer women or allies there who are really helping to like build and support some of that, the sort of fit within your community from a work perspective, I think there's sort of a bit of a risk of compounding. And so one approach that we've found, and then I'll stop my very long answer here, is companies are really nuanced generally in thinking about their customer base. You do really thoughtful segmentations. You say, what are your specific customer needs? How do we meet them? We've got all the tools. We need to be doing that for our employees, right? And particularly for women, so that we can understand what will keep them in and engineers more broadly, so that they're carrying through.
I'd like to add a couple things. So first, as a mother, so I have 5 children, 3 of them daughters, and I got really great advice from an awesome math teacher of one of my daughters that said, don't tell her she's doing a great job and congratulations on getting 100 on that test. Tell her it's good that she's working hard. And I found that while I actually have twins and I saw some of the differences in how they were treated, we tried to treat them the same, but that advice, you're working hard, keep at it. And what I see with the SAE Foundation and some of the STEM curriculum is giving kids problems that they can't solve immediately. They need to look to each other, and it's complicated. And that messiness and difficulty and struggle actually serves kids better as the math gets harder in middle school. You get into algebra and geometry, and the message of you're doing great, you got 100, which works for girls who often can sit still earlier in grade school and they get 100 on the arithmetic, fails when you get to the point where the math gets harder and the problems get tougher, both in the workplace as well as in the tougher subjects in high school and college. So that message of keep working on tough problems and giving problems that are tougher. So that's my message as a parent that I learned, and it has resonated in what I've learned with the SAE Foundation. The other thing I would refer to is some research. I've been a member of the Society of Women Engineers to try to learn on this topic for some time. And they share something on a climate control analysis and research they've done that there are 3 remaining biases that women in engineering face in the workforce. And there are detailed studies for both the US and for India, as well as for other underrepresented groups. But the 3 are a maternal wall bias. So if someone is thinking about having children, do they ask for and do they get the toughest jobs that set them up for future success? A tightrope bias that says the range of behaviors that are acceptable for a woman in the workforce is actually narrower. So if I'm upset, am I emotional or am I, being assertive? There's a narrower range. And so a human being will be less impactful if they can't use their full range of emotions. And so that is a bias that is impactful. And then the last one is prove it again bias. So if someone sees a woman or someone that they don't expect in a role, does that person have to prove their capability and prove it again? So those are 3 things that Society of Women Engineers guides us to say, think about them. And research also shows that if you call out the biases and talk about them before having conversations, they'll have less impact on the conversation or the environment. And so thinking about them, just being aware of them, you can help to mitigate them by talking about them. So just wanted to add those few things.
Joe, let's add some data to this. This is frightening. Only 16% of U.S. engineers are women. How does that change?
I could start on that one, and then Sibley, I know you've thought about that quite a bit. Yeah. Back to the beginning where we said there is no silver bullet. It's a tough problem, and there are societal pressures. There are, engineering classes are tough, and so people have to want to work hard and stay in it. But it's very rewarding because if you take the tough classes, you have lots of really interesting work options. So one of the schools near me is Purdue, and they've had a women in engineering program program for, I think, over 25 years, and they publish a report. And so there's lots of useful information there. It's still not 50%, so it's not representative of the society that we live in. But things like making sure the women feel a sense of belonging, can work in teams, can live in communities. I know when I was going through engineering, I had to go to the men's dorm to find study buddies. I didn't meet any other women in my classes until later in my program. And so now there are a lot of things that are very supportive of women to find that sense of community, to feel a sense of belonging. So that's one that stands out. And Sibley, I'd welcome you to add.
In many ways, it's sort of like the curb effect, I think of it, Grayson. Like, I'm not sure if you all are familiar with this, but from a sort of accessibility and disability perspective, there's this question where they realize that when you're stepping off the street or the sidewalk of the street and you step over the curb, for accessibility purposes, that many have like a ramp or a brake, right, where the curb instead tilts down. And so this came originally from sort of an inclusion perspective, but they found that it benefited not just folks in wheelchairs, but also mothers with strollers, like kids on bikes. There's a whole range of other people who are benefited by that. And I think when I think about sort of addressing the women in engineering gap, which as you rightly call that, it's like only 16% of US engineers today. And frankly, disappointingly, it's sort of plateaued about there. So it's not like we're on really an upward trend. I think about addressing that, and I think about addressing that as actually being something akin to the curb effect, right? If we can create better, broader, more inclusive pathways for engineers who are women, or women who are interested in being engineers, it will actually help the talent pipeline writ large. And just to go back, Grayson, to your point earlier around sort of apprenticeships and like that being one additional path, I think that we need levers both for women and for all potential talent across the full sort of talent spectrum. So that's more dynamic talent recruitment. So that's not just your traditional pools, but also new collar talent, so to speak, maybe folks who have part of a degree but not a full degree, re-entrants to the workforce, retirees, gig workers, right? We need to expand the pool of who we're thinking about in terms of filling these engineering roles. I think as Jen was saying earlier, we need upskilling, right? This is a requirement, not a negotiable aspect. Like there's truly just is not enough talent out there today to fill these roles. So you can compete and try and recruit better and better and pay more and more, but that's not actually going to solve the problem, right? You're just competing from the same pool. So you have to upskill. That means both. Sometimes it's like you hire in the 80% ready role and you upskill the last 20%. Or to Joan's point, it's upskilling in role. It can be transversal across roles. And given the rate of change of skills, I hate to break it to you, you're going to have to do that on an ongoing basis, right? So as an organization, you need to build those muscles. And then to Joan's points, again, around engagement, right? We need to figure out how to be as nuanced in supporting our employees' needs and their various pathways as they are in thinking about our customers. And again, like it actually helps you to be more efficient, right? Because you can be more targeted. You can solve the need that you actually need to address instead of sort of peanut buttering across. So those are just three that I would throw into the mix as we think about the levers that will help us to both have more engineers coming into the workforce, but then also keeping them as their careers continue.
Let's take this one step further and let's give some data here, because the Bureau of Labor Statistics is indicating that the demand for engineering skills will grow about 13% from 2023 to 2031. On the company employer side, how are they preparing for this talent shortage? Are they just going to stop innovating, or how they're going to have to upskill? How are they going to prepare for that?
Yeah, it's a great question. And actually, this 40 by 30 initiative that we're talking about today came from a brainstorming session at one of the SAE Foundation trustee dinners, where I was sharing some frustration that the graduation rate of women in engineering had plateaued around 20% for the past 10 years, and saying, hey, what can we do? And sharing some ideas, but also asking for ideas about, how can we change that? And we were comparing that to the talent gap that we were each forecasting in the mobility industry, and noticing, coincidentally, that if we doubled the graduation rate of women in U.S. universities by 2030 to 40%, that we could close that gap. So as a, dramatic oversimplification of the problem, but focusing on one thing sometimes helps to see a range of solutions that can be helpful other places, like the ramps on the sidewalk that Sibley mentioned. And so anyway, we made that connection. And one of the things we also were talking about is that companies' timelines to hire, as well as sometimes our visibility to the exact roles and exact skill sets, is short. So on the order of years. And we might be able to forecast out 5 years, but that like 10 years, 20-year forecast is tough. But the educational systems change, the pace of change is slow. So it takes a very long time to create the new curriculums, to create the new program pathways, to create the variation of certification that will be needed to, pull in the range of people. And so that like having a range of solutions, but also having connections between some of these entities and companies that can talk to each other and compare notes and then maybe forecast a bit longer duration. And then universities and school systems that can also be seeing that gap and then work with states and work within the school systems to create these options. We're going to have to come together to make those things connect to bridge this talent gap that we have in front of us.
I would just double down on particularly Joan's point around both sort of the more nimble and or more forward-looking strategic workforce planning, but also sort of the coalition building needed in order to cross some of these either cross-sectoral or frankly just time horizon gaps between the timeline that education institutions are thinking about this versus industry versus government, et cetera. You can see when you look at it why it's sort of naturally hard to solve without all those parties in play. The only other thing, Grayson, to your question of what do companies do? I think we've talked a lot about ways to try and minimize or address the talent shortage itself. I'd also just throw in that I think there is a lever around what is the work to be done and who is actually doing it. This is maybe a little bit far afield, but there's been a lot of buzz around generative AI, for instance, recently. And we at BCG have worked with lots of companies on productivity diagnostics. And one of the things that is really important to do is to actually decompose a role into what are the jobs to be done. And then you sort which are the ones that are better for a human to do versus, for instance, an AI-enabled tool. And what we've seen is that this can actually increase for the employee both their productivity, but also the quality of their work and their engagement in the role. Because what you can do is you can sort of outsource some of the grunt work, which frankly is great for that is beneficial for everyone, but you're keeping the parts of the job that you can find most meaningful. So I think that's just a really interesting extra lever to put into the mix is like what actually is the work that we are saying needs to be done? And then what are we having people do versus what are we leveraging sort of the other tools in our arsenal to do? So just one more way to sort of think outside the box as we're addressing some of these shortages.
Thinking outside the box is critical. So you have that one solution. But what are other things that companies do to retain the talent? AI talent is very hot. Companies are poaching left and right. But how are companies going to retain the talent when there's such a shortage? So when the shortage there, you have economists, the price tag goes up and somebody's going to keep outbidding somebody. So how do you, as a company perspective, how do you keep these individuals at the company?
Yeah, I could start on that. I mean, there's no substitute for managers, teams working together and valuing each other and trying to bring out the best in their team. So making sure that we connect with everyone that is coming in, leverage their talents, support them to success, create a sense of belonging for diverse teams is, just the table stakes to make sure people want to work in the team and can contribute their best. Thinking about how to put together teams as well and making sure managers have training. I know we do things on just training for managers, basic planning for the team, and sense of belonging across both virtual as well as teams that work in person. Sibley mentioned AI and thinking about how to make jobs more meaningful so that the complexity of the work might go up or the value add that the humans can contribute goes up is a great point as well. So I know within my team, we have some AI co-pilots we're using for some portions of the coding that we do that helps with the testing of the content, that helps with the structure of the code. We still need human beings to figure out what the outcomes are that we want out of that code, but that increasing the value of the scarce engineers that we have and making them work, helping them work together in more efficient ways. And there's lots of tools, but there's also lots of just focus that leaders need to put into that and creating the right environment, both the physical environment as well as the virtual environments to enable that collaboration and support.
Sibley, your thoughts?
I think if you're trying to figure out how to engage your employees and how to keep them sort of retained within your organization, you have to go to the source in so many ways. Like we talk about this idea of being proximate to the problem. You actually have to segment your employees and understand the experience and the barriers of your different populations. So that could be women, that could be younger folks. You see all these headlines about Gen Z, right? What does Gen Z think? How are they integrating? Right. And so again, we have the tools to do this. We do this with our customers, but we don't necessarily do it with our employees internally. And so I would just echo again that when you do that, that's when you can then sort of parse these challenges around, for instance, sort of what I say is going to keep me versus what actually retains me. And you can get to Joan's point, sort of what are the drivers that will keep those individuals engaged and invested? So we do see from our research that, again, sort of the role of the middle manager is critical in terms of keeping talent. And again, responding to sort of those emotional needs, not just the functional ones, but it will be different for different groups in different contexts. And so just really encourage folks to do that sort of looking internally and getting sort of proximate as you're thinking about levers there. Maybe one just story or example here that I've found very compelling of a time when this worked, Grayson. And this is not engineering, it's actually in terms of sort of plant operations. But we had a client where they were looking at their sort of frontline workers in their plant operations, and they were like, there's this big pay equity gap between the women and the men working in this plant. Like, what is that about? And they drilled down and they saw that actually the men were taking a lot more overtime shifts. And then they did some focus groups, and the women weren't not interested in the overtime shifts, but what they were saying was they were like, it's really hard to find a babysitter because of the hours of the shift. And so what they did was they actually shifted the hours. I think it was 7 to 7, and they shifted it a little bit earlier because it's much easier to find a babysitter in the evening than it is in the morning. So if you're looking to sort of bridge a few extra hours so that you can take that overtime shift and then also the overtime pay associated with it, that little shift in the hours had a really big impact. It didn't entirely close it, but it made a big difference in the ability for the women who were equally capable to actually take those overtime shifts as well and then reduce that pay disparity. So that's just sort of one small example of what can happen when you actually sort of go to the source and understand from an individual's perspective, like what are those barriers? Like to Joan's example in Dubai earlier, is it the fact that there isn't a bathroom, or is it a fact that there's some other sort of impediment or chilling effect?
I want to add one thing. That's a great point of going to the source. And Sibley, I do a lot of that. And we at Cummins do a lot of that, like focus groups with sub areas of the organization and really listening and learning. And one that I found actually surprised me. I have 24 patents, and I met someone who was doing research on women in patents. And when I gave a talk and I just mentioned that and didn't think it was a big deal, she said, I've never met anyone like you. And I said, what do you mean like me? And it turned out a woman living in the Midwestern United States who works in the automotive industry who has more than 5 patents. I'm like, that's very specific. But then I started looking around and saying, oh, actually, I work with all these teams to invent, but the percent of women is lower on some of those, even in a very inclusive culture like Cummins, and started looking into what does it take when you're doing a really tough problem to contribute to that invention. And there's a lot of tenacity. And there's also a little bit of like, I'm staying in this with this team, and this trust of like, when the person that's leading the effort, who do they call and who do they most trust? And this in other industries, like in startup companies, and it actually translates to dollar rewards when people stay in and invent or start companies. So I started to look into this, who invents, and the research on women top inventors pull in more other women first inventors. But this element of who do you trust to when you have a really, really tough problem is important. And often those people that solve tough problems on an ongoing basis are the ones that end up in more senior roles and might stay in engineering longer. So there's something there that I've been learning about and really think is important as a leading indicator of what are some of the things we need to think about and change to get more women into engineering and help them stay there and really contribute to the toughest problems.
And see, Joan, I would never have known that this trust factor in that particular type of context has such outsized import. Mm-hmm. That's super interesting.
Joan, what causes that trust gap?
Well, I mean, just very basic human nature. If I'm scared, if I don't know what's going on, you'll just look to somebody that you're comfortable hanging out with, and a diverse team that's visibly diverse, maybe from different countries of birth, maybe different genders, other dimensions, maybe different educational backgrounds or growing up. It is just natural as a human to trust people who look like and seem like you. Right. And so we have to expend energy and get through that messiness of getting to know people that might not be ones that would show up at my family reunion, to feel comfortable and have that same level of trust. Like, what's that first instinct of who would I go to with the really tough problem when I'm scared and uncertain? And getting through that and actually consciously pulling in a diverse team, you'll end up with better outcomes, but it's messier to get started.
If we can close the trust gap, does that eliminate part of the drop off? Perhaps there's an engineer inside of Cummins or another company that drops off, says I'm done with this, but that trust gap is eliminated?
Well, it is like a series of really tiny choices over a long period of time. So if there's a woman or any engineer or anyone that doesn't get pulled into those toughest problems, then they're not seen as someone who solves those toughest problems, and they're not given the next tough problem. And then when you look around and you want someone to lead an important initiative, they may not be pulled in. And so it's not like any one thing. It's this series of things over time that when a woman is busy and has been up all night because her third child didn't sleep and she's at work, she's like, oh, do I really want to keep doing this? But if her job is super important, she's more likely to stay.
It comes down to caring. It's caring. And then but before you can care, let's go back to children. You have to explore. You really have to explore. Sibley, is the rise of Gen AI encouraging more kids to potentially explore careers in engineering? Perhaps they start with a photo app and they generate a photo of I saw a photo of a bear on a skateboard today that was made in AI. Perhaps it's something like that. Oh, that's cool. How is this done? Does that start that potential path towards an engineering career?
I love your example of the bear on the skateboard. I don't know if you guys have played around with Gen AI much. If you haven't, I encourage you to. One of my fun things from Thanksgiving last year was trying to get all of my family to actually play around with ChatGPT. So again, if you haven't done it, I encourage you to. But it's interesting. There's actually some interesting data around what kids are using Gen AI for today. So this is middle and high schoolers. And of course, this is a fast moving space, but about 3/4 have been using it for sort of creativity related tasks. So think like make me a meme or the bear on the skateboard. Another 1/2 to 2/3 are using it for entertainment, but then about 1/3 are using it for help with schoolwork, which I don't know if you guys have seen Gemini, which is one of Google's models, released sort of an example of their capabilities as like a tutoring chatbot. Here's my snip of my homework. I don't get this question. Can you explain to me how it works? And so I think there is a really interesting potential for Gen AI and these sort of conversational chatbot tools in particular to actually help kids explore new creative topics like generative AI. But I think also to your point, Gen AI, I think, is going to not just help people learn about topics, but also prompt their curiosity in it. So this question of, wait, how is this actually built? And by the way, there are actually a ton of open source resources out there. I can build a custom GPT from my bedroom. I can go on Hugging Face and I can get the data sets and I can actually fine tune a model myself if I want to, right? There are actually, and I see Joan smiling here as well. Like, I think there are actually a lot of opportunities for generative AI to both sort of prompt that curiosity, but then also be a way to learn about engineering skills more broadly as well. I'm optimistic.
Yeah, I did. We also have 3D printers in our house. It sounds like you do as well, Grace. And that's another thing that, engineers that had manufacturing limitations to their designs in the past now have to sort of learn and open their minds to new ways. But my kids who just print whatever they can imagine don't have those limitations. And so kids can experiment. I think in the entry to that experimentation, it has a much lower bar. So I think that will just encourage people to feel comfortable with technologies and just integrate them into their thinking from an early age, at least if we can make them accessible to kids broadly. And anyone that has access to those will just be thinking of them as part of life.
Doubling down on Joan's point around access, I do think that while the potential is really high, there's also a risk of sort of a third digital divide in terms of access to these tools. So I'll just agree. I think as a former teacher myself, like there is opportunity everywhere, and kids are so curious and creative, and they actually, again, to this day, they like to learn, they like to explore, and so I think that the access point is just critical to make sure that we're making that available for everyone.
Absolutely, Joan. We talked earlier. There's a shortage in electrical engineering, software engineering. Kids are learning skills. The generative AI is a software skill. Is there an engineering skill that's the most portable, that if you want to use that as a foundation that can be built upon, perhaps to go in other different niches inside of engineering?
Definitely. So problem solving, understanding what problems are relevant to solve, and then using different models to apply engineering calculations to address them. And the tools change, the approaches in how we interact with each other, whether it, Zoom and other virtual ways, or in rooms with Post-it notes, or using 3D printers or Gen AI to prototype things. The tools change, but the general understanding what challenges we face, and that tenacity and applying different mathematical or science-based models to think about the solutions and test them quickly is the basis of engineering, and what is most portable across all of this evolution that we're in the middle of and will face in the future.
Sibley, in your opinion, what does the future of work look like? One thing we can agree on is changing a lot, but in your opinion, what does it look like?
It's a good question. Well, I will say I think there's going to be more dynamism in the skills needed, in career ladders and flexible options, in what people do versus what the technology does. And I think that will hopefully drive both more business value, but also more value for individuals and employees. And I think that as we look at that sort of transition to that future, Grayson, whether it's the post-pandemic return to work or the energy transition that Joan was speaking about at the outset, I think there's a real opportunity to look at these for chances to increase equity in the workforce versus just reinforcing the biases of the past. So I know there's actually some really interesting research out there around green jobs and green tech, and who traditionally has been in those roles, and then how you can make those sort of more diverse and inclusive. And I think we have an opportunity here, to your point on that piece around sort of the dynamism and the speed at which it's changing, to really transition forward for the better.
Joan, what are your thoughts?
I think people need to interact with each other for ideas to really progress and share ideas. And, there are many people that know many different things. And as problems get more complex, that interaction of humans and exchange of thoughts becomes ever more important. But the ways that we can do that across time and space are evolving. And so, for me, I really enjoy having in-person conversations. For some of my kids, actually, one of my kids' best friends lives in Sweden, and I don't think they notice that they're talking on phone and playing video games across time and space. So I hesitate to forecast, because I know that the methods will evolve significantly over time. I mean, maybe we'll have avatars in our Zoom meetings instead of videos at some point, so we can have side conversations like you do in a normal working session, and imagine how we want to show up. But I do think that connecting people and arraying ideas towards solving meaningful problems will be a constant, and human beings will constantly find ways to do that.
Human beings are special. We probably don't even understand a third of what we're capable of, and we keep evolving and we keep changing. This has been a really important conversation. It's also been an insightful conversation. Joan Sibley, I thank you so much. And as you look to wrap up this insightful conversation, what would you like our listeners to take away with them? And Joan, we'll start with you, please.
We have a problem to be solved in a talent gap in STEM to enable our transition to low carbon mobility options in our industry. We can contribute to solving it in a number of ways, and likely what we're each doing locally in our own space, in our company and a university, won't be sufficient on its own. So reaching out across those boundaries will be important. And then the other thing that I've learned through some of the discussions with universities is the imperative to diversify our engineering enrollment in universities and in our companies is no longer just the right thing to do, but it's actually a survival imperative for universities and the companies that will hire from them for engineering. So it's an exciting time to be an engineer, and I would also like girls to aspire, and anyone that's interested in solving meaningful, tough problems to be able to enter engineering and contribute.
Well said. Sibley?
It's interesting. So BCG surveys CEOs annually on their top priorities, and across sectors, talent is one of the top 3. So I think, Joan, to your point around the urgency, like folks are feeling it. And so I think the moment is now to reach beyond just the individual activities or initiatives of your organization and to really be cross-sectoral. And in order to do that, we just need the leadership and commitment to address. So I'm optimistic.
Optimistic is a wonderful thing. The moment is now. Today is tomorrow. Tomorrow is today. The future is engineering. Joan Sibley, thank you so much for coming on SAE Tomorrow Today.
Thanks for having us.
Thanks for inviting us.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week to hear about WIS's mission to make sustainable autonomous flight a reality.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.